So this is a video on section 5.1, which is proving identities. And really this covers a lot of material from the rest of chapter 5 as well. This is just a particular skill that needs to be developed. So in order to do this, we first need to remember our previous identities. So the first category of identities is the reciprocal identities. And there's there's three. There's just a couple of ways to write them. So the first is 1 over sine is equal to cosecant. And the opposite of that, which is 1 over cosecant, is equal to sine. The second one is that 1 over cosine is equal to secant. And very similarly, 1 over secant is equal to cosine. The third and final category of reciprocals is 1 over tangent is equal to cotangent. And similarly, 1 over cotangent is equal to tangent. So these are ones that you should already have memorized. The next category is called the ratio identities. And those are basically where it's a ratio, which is a fraction. So two trig functions in a fraction. So the first is that tangent of theta is equal to sine over cosine. And then the second one should be no surprise is that cotangent is that flipped over, so it's cosine over sine. And once we have our ratio identities, it brings us to the third category of identities that you definitely need to have memorized. And the third category is Pythagorean. So there are 3 Pythagorean identities, but really there's one main one, and then there's some ways you can manipulate it to get the others. So the main one is sine squared. And let me make a quick note. When we write it like this, we really are meaning this. We just move the 2 for convenience so we don't have to deal with parentheses. So it's sine squared plus cosine squared is equal to 1. For the next 2 Pythagorean identities, you can just kind of manipulate this one. So we're going to do 2 different things. The first thing we're going to do is we're going to divide by cosine. Divide everything by cosine squared. So we're going to take our original Pythagorean identity, we're going to put it there, and then we're going to divide everything by cosine squared. And once we do that, we're going to simplify. So sine squared over cosine squared, hopefully you remember from ratio identities, that's just tangent. Cosine squared over cosine squared is going to simplify to 1. And then we have 1 over cosine squared, which is equal to secant squared. And that is our second Pythagorean identity. So the third one is going to be very similar. It's just instead of dividing by cosine squared, we're going to divide everything by sine squared. So same idea, we're going to start with the original formula, and then we're going to divide each term by sine squared. So when you do that, we will simplify. Sine squared over sine squared is just 1. Cosine over sine squared is cotangent, if you remember from ratio identities. And then 1 over sine squared is cosecant from reciprocal identities. And that is the third and final Pythagorean identities. And that is really a summary of everything that you need to have memorized. So that is anything beyond that, identities will be given to you on a formula sheet. But these you definitely need to know. So that's really the background info that we need to be able to prove identities. You need to know your reciprocal, ratio, and Pythagorean identities. Before I jump into examples, I'm going to give you some strategies for how to approach these proving identities problems. just because it's a weird type of problem. It's a little unusual. So before I give you the strategies, let me tell you what I even mean. The problems will look like this. It'll say prove sine theta times cotangent theta is equal to cosine. And your goal is to manipulate one side to look like the other. So in this case, we'll manipulate the left-hand side, but it doesn't have to be the left. It's just the more complicated one. We manipulate one side until it looks like the other, till it matches the other. So here are the strategies for how to approach this, because manipulation can be a lot of different things. Like sometimes we'll make a swap. We'll put in sine over cosine instead of tangent, or maybe we'll simplify something or whatever. But the first strategy is going to be start with the more complicated side, because it's usually pretty easy to simplify, but it's much, much harder to make something more complicated. So we're going to start with the complicated side. Number 2, we're going to look for the basic identities. So those basic identities are the ones from earlier: the ratio, the reciprocal, and the Pythagorean. So if you notice in the problem you've got a sine divided by a cosine, your brain should say, oh, wait a minute, that's equal to tangent. Also, this Pythagorean identity, sine squared plus cosine squared equals 1, shows up a lot. If I rearrange it a little bit, it'll look like 1 minus cosine squared. So that's subtracting cosine from both sides. Or I could subtract sine from both sides. And both of these expressions, 1 minus cosine squared, 1 minus sine squared, those will show up. And that is an example of looking out for your basic identities. If those show up, you might swap them out for sine. So instead of 1 minus cosine squared, you would write sine squared. So that's what I mean by look for basic identities. You should recognize that it matches one of the formulas that you have memorized. So strategy 3 is going to be use algebraic manipulation. So what I mean by that is you might add fractions together. So that means give them a common denominator and then add or subtract them. You might distribute something over a set of parentheses, or you might factor to simplify a fraction. So those are very common techniques that we will use to manipulate one side. Number 4, if nothing else is obvious to you, change everything to sine and cosine. So you put everything in terms of sine and cosine. That means instead of tangent, you'll write sine over cosine. Instead of secant, you'll write 1 over cosine. It makes it a lot easier to cancel things, simplify things, combine like terms when it's all in terms of sine and cosine. Okay, so strategy number 5 is going to be keep an eye on the side you're not touching. So the rule for proving identities is we're only ever going to touch one side. So you're only going to manipulate a single side. But while you're doing that manipulation, you want to keep an eye on the side you're not touching, because it might give you some hints. For example, if the other side has like a cosine in it, you know that your side, the one you're manipulating, also needs to have a cosine in it. So that might help you kind of know what to do next. It might give you a path for how to go. So as you're doing this, you always want to keep an eye out for the side you're not touching. Okay, those are our basic strategies. So once you have that info, we can actually do some example problems. And for the record, we're not always going to use these exact strategies in this exact order. They're kind of just things that you look for, things that you keep in the back of your mind as you're working through these problems. So I'm going to start with this example I put at the top. We're going to prove that sine multiplied by cotangent is equal to cosine. So I noticed that I can actually use strategy 1 always because the more complicated side is on the left. So I'm going to start there. On the left-hand side, we're going to manipulate whatever we can. And I see this cotangent in here, and I know some basic identities about cotangent. And if you remember them, there's a ratio identity. Cotangent is equal to cosine over sine. And that also is strategy 4. It will put it in terms of sine and cosine. So I'm going to swap out cotangent, and I'm going to write sine multiplied by cosine over sine, which is equal to cotangent. And then, looking at this fraction, I've got a sine on top and a sine on bottom. Those two are going to cancel, and I'm left with just cosine. And that, simple enough, matches the other side of the equation. So I have finished it. I've proven this identity. If you want to, you can put a little square. That says the proof is complete. So we're going to do some more examples, but we're going to follow the same basic strategies. So this next example is going to be prove that tangent x plus cosine x is equal to sine x multiplied by secant x plus cotangent x. As always, we're going to start with the more complicated side. And the more complicated side, in this case, is the one on the right. And looking at the right, I see these parentheses, the sign outside. I'm going to go ahead and distribute the sign to these other two terms. And that is the strategy 3. Distribute is one of the algebraic manipulations. So when I distribute, I get sine x multiplied by secant x plus sine x multiplied by cotangent x. From here, I can use my basic identities, and I can put everything in terms of sine and cosine. So instead of secant, I'm going to put 1 over cosine. So I'll have sine x multiplied by 1 over cosine. And then for the second term, I'm going to have sine x, and I'm going to swap out cotangent. I'll put cosine over sine. Then, in the second term, you might notice there's a sign on top and on bottom. Those two are going to cancel. And then for the first term, I'm just going to go ahead and multiply them together. So sine x multiplied by 1 over cosine, that's just going to be sine over cosine. And froze. There we go. Okay, so we're going to have sine over cosine plus cosine x. And then we're almost there. You might notice that we've got this plus cosine on the other side. So strategy 5 is keep an eye on the other side. And all that's left is to swap out sine over cosine for tangent. And that matches the other side. So we are finished. So yeah, that plus cosine matched. All we needed to do was replace sine over cosine is equal to tangent, the only thing missing. So we're finished. I am going to do, I think, 2 more examples. So this next one is going to be prove that cosine to the 4th power minus sine to the 4th power divided by cosine squared is equal to 1 minus tangent squared. Okay, before I do this, I think I want to talk a little bit about factoring because we need to simplify this complicated side, this fraction. But in order to do that, we really need to factor. That's how you simplify fractions. You factor the top and bottom, you cancel whatever you can, and then it will end up simplifying. So that's the strategy here. We're going to need to factor it. But in order to factor it, I think I want to put a little note here. So when you're factoring, there's a particular form you should keep an eye out for. So we're going to keep an eye out for difference of squares. And if you don't remember what difference of squares is, I'll go into that a little bit. So difference of squares is whenever you have something of the form a squared minus b squared, it will factor a plus b times a minus b. So anytime you've got two things that are both perfect squares, that means they're both something squared, it will always factor as a plus b and a minus b. You've got a plus version and a minus version. So for example, if you have 1 minus sine squared, that's 1 squared and sine squared, so it'll be 1 minus sine times 1 plus sine. The plus or minus order doesn't matter. Or another example is you could have like tangent squared minus 1. Actually, you'll probably more likely to see cosecant, so we'll put that. Cosecant squared minus 1, that's just cosecant minus 1 times cosecant plus 1. So if you need more reminders of difference of squares, I would literally just Google that phrase. Google difference of squares. Because this problem is actually an example of it. This is a difference of squares. In fact, it's cosine squared squared and sine squared squared. So the first thing I'm going to do is rewrite it like that, just so it's a little clearer what we're dealing with. And now that it's been rewritten, maybe you'll see that that is, in fact, a difference of squares. It's a squared minus b squared. So it will factor as a minus b and a plus b. So that's the first thing I'm going to do. I'm going to have, instead of cosine squared squared, it's just going to be cosine squared minus, and then the plus version, cosine squared plus sine squared. And my denominator I haven't touched, so it'll stay the same. Now you may recognize cosine squared plus sine squared. This term right here is one of those basic identities, and in fact, it's the Pythagorean identity. Sine squared plus cosine squared is equal to 1. So that whole term is actually just going to go away because it's just a multiplication by 1, which is going to change nothing. So I can just not write it. This is as easy as cosine squared minus sine squared divided by cosine squared. From here, if I'm keeping an eye on the other side, I notice there is not a fraction on the other side. So I need to get rid of the fraction. So yeah, it's just it's two individual terms. There's no fractions there. So to get rid of that fraction, I'm going to go ahead and perform the division. So I'm going to go ahead and divide by cosine squared. So I'll divide the cosine squared by cosine squared, and I'll divide the sine squared by cosine squared. And once I do that, I can go ahead and simplify it. So if I simplify, cosine squared over cosine squared is just 1. And then look, it's really starting to look exactly like this guy. We've got a 1 minus, and down on mine we have a 1 minus. All we need is to simplify sine squared over cosine squared, and that is in fact equal to tangent squared. So there we go. We got 1 minus tangent squared, and the proof of our identity is complete. So I'll do one more example, but as I said, we're going to do this same strategies in all of chapter 5. So the last example is going to be prove that 1 plus cosine x is equal to sine squared x over 1 minus cosine x. So the right-hand side is definitely the more complicated side. So I'm going to start by messing around with this right-hand side. There's a lot more going on here. And I need to simplify that fraction. The other side doesn't have a fraction, so I'm going to need to get rid of it. But it's kind of hard to see how anything could factor or cancel because the top is in terms of sine, the bottom's in terms of cosine. They really both need to be in terms of sine, or they both need to be in terms of cosine. We could change the sines into cosines or vice versa. That would be ideal. So in order to do that, I'm looking at the top, And I notice that we have a sine squared, which reminds me of the first Pythagorean identity. So if you remember, we can rearrange this a little bit by and get 1 minus cosine squared is equal to sine squared. So we've got a sine squared on the top. We could swap that out. Instead of sine squared, we could put 1 minus cosine squared. And then everything will be in terms of cosine, which will make it a lot easier to simplify. From here, I'm looking at the top and I notice that this is a difference of squares. So I'm going to go ahead and use that because I know I need to factor because this is a fraction. And to simplify fractions, we have to factor. So it is a difference of squares. If you remember, it's a squared plus b squared. In this case, it's a squared minus b squared. So it's going to factor as 1 plus cosine and then 1 minus cosine. And once I do that, you may notice that we've got a 1 minus cosine x on the top and on the bottom. Those two are exactly the same. They're going to cancel. And once we do that, we're left with just 1 plus cosine x, which exactly matches the other side. So we are finished with this problem. This is most of what you're going to see in chapter 5. You're going to do a lot of proving identities. They're going to look a lot like these. The only thing is there will be some new formulas, some new identities, in addition to the ones that you have memorized at the beginning. So right now we know ratio, reciprocal, Pythagorean. There will be more identities. And the good news is you don't have to memorize all these new ones. So I'm just going to say check Canvas for the formula sheet because the formula sheet is going to have all of the other identities on it, the ones that you don't have to memorize, and that will get you through the rest of chapter 5. So you can just use the formula sheet as you're going through this, and besides that, just practice these strategies. Good luck.